key distribution. And as I told you earlier, that we should use a different medium than our communication medium for distribution of key or for sharing of key with other nodes or with the receiver. Most important component in secure communication is the key distribution. So no one should be able to get some clue about your key. Here in case of symmetric key encryption, the delivery of symmetric key is a huge challenge. And the reason is that both sender and receiver are having the same key. And if it is leaked or someone get any clue about that key, then he can decrypt all information in the communication process between both computers. Therefore, as I told you that we should select a different medium than our communication medium for communication. Here you can see in communication between node A and node B. A select a key and physically deliver it to B. So look at this. They are not using the same communication channel, but they meet somewhere in a restaurant, somewhere in the university, in the cafeteria, and they share the key with each other. Another approach is that there may be a trusted third party which is responsible to deliver your key to your destination node. Yeah, please. Is there any question from your side?
Yeah, I think Jonathan was trying to ask. Go ahead.
Please.
Could you please mute your mic for the other account, the Mizum Ali Khan? It's feedback on the other one.
Is it fine now?
Now your computer's feeding back on itself.
All right. So here the KDC, a key distribution center, can be used which select a key and physically deliver it to A or to B. If A and B already have a viable key, it can be used to distribute a new key. And let me explain it here on the whiteboard that here is the sender node and this one is the receiver node, and they are communicating with one another through their personal laptop, which is connected with one another. So look at this. They don't use the same channel So that's why both of them can meet somewhere in the restaurant, in the university campus, in the classroom, or you can say in the cafe, and share the key. So if there is even any attacker sitting over here, then he will not be able to get any information. Attackers are bypassed by using a separate channel, and that's why this is more secure way to distribute your keys. And the second one is that you can have a third party as well. Here, moving in the same example, that you have a third party over here, and that is the KDC, Key Distributed Center, and you are sharing it with the receiver. So look at this, your own communication channel is this one, and you are using the KDC, that is another channel for key distribution for key distribution. So another is public key management, which is actually asymmetric algorithm in which we have different keys. So you can see that asymmetric keys can proliferate and store on keyring as well. Even asymmetric key distribution need care, and similarly main and middle attack as well. The distribution of those public keys can be through public announcement, through public directories, through public key authorities, or even you can use it through public key certificate. And use of public key encryption to distribute secret keys as well. You can also use your public key to distribute as well. And this is so as I told you, we have two type of keys, public and private. Public key is available to everyone, and it means that anyone can access it. If anyone want to communicate with the user, he can use the public key to communicate with the user. So you can publish it, you can put it in any public place, in any public directory, you can advertise it, you can announce it, you can share through any middle person, while private key is your, remember this public key is used for encryption of data, while the private key, which is only known to receiver, and this key is used for decryption of data. So both these keys are different from each other. They are different from each other. While in symmetric key, the key is same for both sender and for receivers. Similarly, you can see here in this diagram, there may be the possibility of a man-in-middle attack on symmetric key. And here you can see that sender write a message, encrypt it with the key, and look at the step 2 over here. He used the public key, that is key bad, and then onward he used the same key over here, and they decrypt the message and have access to the actual message. So this person is actually the man in middle, and he get this key with the help of your public key while you are sending it to the other node. So there is also a possibility that someone can hack your key or can hijack your communication and get access to your secure key and can decrypt your message. Another important security technique is the SSL, that is secure socket layer, which is available on transport layer, and that's why it is also called transport layer security services. It was earlier developed by Netscape, and I hope you know about the famous Netscape Navigator version. Version 3 designed with the public input and subsequently the internet standard known as TSL, Transport Layer Security, which uses TCP to provide a reliable end-to-end service. There are two layers of SSL, and you can see over here in this diagram where the SSL exists below application layer on one side, on the right side, and on left side there is no SSL. So with this right side you will have more secure communication as compared to left side. Similarly, if you look at the application layer, then there is a bit modification in the protocol HTTP that is converted to HTTPS, that is secure version that is used with secure socket layer. And similarly, you can see SMTP protocol that is converted or modified or updated to SSMTP, that is secure simple mail transfer protocol. And similarly, the port number of that protocol is also given here is 465. Whereas POP3, that is Post Office Protocol 3 version, that is used for mail delivery, remain the same. Similarly, uses a public key scheme. Each client server pair uses two keys. As I discussed earlier, there are two keys. One is for client browser and the other one is for server. So the one for clients browser created when browser is installed on client machine. When you install that browser, then automatically it will have that specific key available over there for communication. On the other server side, you can see that it is created when server is installed on server hardware. There are two private keys as well, one for client browser and other one for server browser. And that's why both have the same, both have different private keys. The example of encryption here in SSL, where it is used between web server and browser for secure communication. And the example is also given, like you want to share the credit card number for payment. Therefore, the server is responsible to verify your information with certificate assuring that the client is the exact person what he claims. Similarly, asymmetric cryptography is used to establish a secure session for bulk of communication during that session. So it means you will have two different keys available. For encryption, you will use public key, while for decryption, you will use the private key. On the other side, the user authentication, which is also a very important activity to identify that either the user is authentic to use this service. It is crucial to identify user correctly and is a new parameter to protect your system. It depends on the user ID, where user identity is most often established. That is a very common technique, that you use the password to authenticate someone, or you can use some sort of code as well. So you can also include some other attribute as well. For example, password must be kept secret. And you have seen the new technique adopted by many organizations, that you have to change your password every week. Similarly, your password may have capital words, your password may have small words, your password may have special characters. And similarly, your password may have any other character like special character. So there are different demands, and similarly your password may be more than 10 words. Maybe it is sometime more than 15. So though it's very difficult to memorize such password, but still to keep the system more secure and to keep the probability minimum that anyone can have any idea, or they can presume that what the password of this person would be. Like sometime many students use their date of birth, their class registration number, their ID number, their car numbers, and their name in opposite, and these are their mobile phone numbers, their address they can use as a password. So anyone can easily guess all those passwords. Therefore, they actually have some limits and some compulsion that is imposed by the system on the user. So look at this, you have to frequently change these passwords, use of non-guessable password, and log all invalid access attempt as well. If there is any, like for example, if you have multiple time entered wrong password through your computer or through your iPhone, then there is a mechanism that invalid accessibility would be reported, and the system will also block that specific device. The password may also either be encrypted or allowed to be used only once. Sometimes there is possibility that you can only use a password once, just to ensure more security. Defense in depth is most common security theory, and it means that you have security at multiple layers. And the main important thing over here is that you are creating a buffer zone between users. You can see over here, for example, this is your server room, and you have a multi-level security. Number one is the physical security, as we discussed, then the human security, then after that the software security, and over here this software security can be in terms of firewall, software firewalls, and over here you can have the hardware security, and it can be the hardware firewall as well. And similarly, you can have the internal security such as antiviruses. And similarly, more internal security by dividing your system into multiple parts. For example, you keep, if the attacker enter from here, then you can save the most confidential information, the most secret information here at the last stage. So you are engaging the attacker here at multiple level, and you are creating a buffer zone as well. So the attacker will first breach the physical, then the human, then the software firewall, then the hardware firewall, then the antiviruses, and these are actually the multiple levels of security. The multiple level of security. So the attacker will be engaged here in all those spaces, and look at this. This is 1, 2, 3, 4, 5, 6, and that's why you have enough time that you can protect your resources as much you can. But it is a time consumable job, and the efficiency of the system will go down. The efficiency of the system will decrease. So intrusion detection endeavor to detect attempted or successful intrusion, such as signature-based detection, spots known bad patterns, anomaly detection, spot differences from normal behavior, and you can also see it can detect zero-day attack, which is a zero-day vulnerabilities refer to a hole in software that is unknown to the vendor, and this security hole is then exploited by a hacker before the vendor becomes available. And that's why it is very famous that mostly your software developers are involved to launch a virus against your software, and then again they develop the antivirus for that virus. So they sell both software and its antivirus at the same time. Similarly, you can also have the false positive and false negative problem, the virus protection, and auditing, accounting, and logging of all activities. Similarly, as we mentioned, that you can have the firewall protection system as well, and the firewall can be in terms of software firewall and hardware firewall. A network firewall is placed between trusted and untrusted host, and the firewall is responsible to check all the traffic that pass from one side to another side. The firewall can be tunneled or spoofed sometime, where tunneling allow or disallowed protocol to travel within allowed protocol. And here he can give the example of telnet inside the HTTP, which is used for remote access to any system. Telnet is the most famous protocol with the help of which you can access a system from remote location. Similarly, you can also have the personal firewall, which is again on the software layer. The system call firewall can also monitor all important system calls and apply rules to them. This program can execute that system call as well. So if there is any system call, then you should verify or you should stop over there for verification before it go for its execution. As I told you that with the help of these techniques, we define a DMZ, a demilitarized zone. The purpose of this demilitarized zone is that you can engage any attacker and take some time to protect your computer resources, your data, and your information. So you can see here in this diagram that there is internet and then the computer company, and here they install a firewall that provide a demilitarized zone for any unauthorized, yeah, you can say unauthentic access from the internet to this computer. Okay, this access between DMZ and company computer is given over here, and DMZ access from the internet over here. So first the request or the query will come to the DMZ, then onward it will be verified. Either it is from a taker, either it is from the user, and for example, once the verification is done, then it will be forwarded to the next node. Here you can see the computer securities classification that is done by US Department of Defense. The US Department of Defense outlined 4 divisions of computer security, that is A, B, C, and D. And that's why I told you that security is important, but security also have some negative impact on your system in terms of efficiency, in terms of performance, in terms of high overhead and high delay as well. So looking at the US Department of Defense division for this strategy, D means that this is the minimal security. Similarly, C provide discretionary protection through auditing, that once they will audit you, and then it is further divided into C1 and C2, where C1 identify cooperating user with the same level of protection, while in C2 they allow user level access control. On the other side, the next step is B, or the next division is B. All the properties are C, and however, each object may have unique sensitivity levels as well. And that's why it is divided into B1, B2, B3. So look at this based on the sensitivity mechanism, as I told you on the whiteboard, that you can divide your data into multiple portions. What are the most secret information, what are the less, then less, and you can categorize them like this. So that's why they also divided into B1, B2, and B3. And the next level is A, which uses formal design and verification technique to ensure the overall security of the system. Here he has given the example of a Windows server where security is based on user account. Each user has a unique ID where login to ID creates security access token. So it includes security ID for user and similarly for the group, and then onward you can assign the special privileges. If you know about or you have done the computer networking, that we have some courses like CCNA and CCNP and CCIE. So these are the certain courses in which you have a particular structure of Active Directory, and this in this Active Directory you actually define that how you can define the role and access for every user. As I told you that either you want to give the access to read, the access to write, the access to create, the access to execute, the access to modify or alter, and the access to delete. So these are different accessibility parameters you can assign to any user based on your requirement. So you can easily configure, and similarly you can configure for single user, and you can configure it for a group of user. And similarly, if you want to give this privileges, you will just put it in the group. For example, if you can see in your university domain, they have divided the system into multiple parts. For example, these are the groups at UMKC, and these are the students. Then onward, the faculty, the researcher, the administration, and the visitors. So look at this. For example, if there is a new user, his name is ABC, what is his status? And you will automatically, if he is from faculty, you will put him here. And you have already defined all the characteristic. You can see, you can give it to him, or this. So you can put these sterics on it. For example, on student, you have 2 sterics. Then on visitor, you have 1 steric. On faculty, you have 4 steric. On researcher, you have again 3 sterics. And on administration, you can say 5 steric, that you have given access to everything to these users. So it means if ABC is from here, XYZ is from research, so you will just keep them in that group or in that list, and automatically WO is here in administrator. So automatically all these stars will apply on those people which you have added in this group. So look at this, uses a subject model to ensure access, security of such subject traits, and manage permission for each program that a user run. Each object in the Windows has a security attribute defined by a security descriptor. For example, a file has a security descriptor that indicates the access permission for the user. And you also have this experience that if you have any Word file, you have any PPT file, you can protect it. You can protect your MS Word, your PPT, your Excel file with the help of password. So you can, and similarly you can make it only readable. You can allow them to write, and you can allow them to execute and delete as well. So now these permissions are very common for all these files. So this is our today's